Hello everyone and welcome to this video. So in this video, I decided to share my experience as a mechanical engineer at Purdue University. So I have graduated from Purdue University with a mechanical engineering degree, and I structured this video with questions that I think I would ask myself if I was interested in mechanical engineering. So hopefully throughout the process of answering these questions, I am able to bring to light some key information about mechanical engineering, as it pertains to the internship work that you would do, the coursework, the job opportunities as a mechanical engineer, hopefully to better inform you in your decision if you should choose to pursue mechanical engineering in your undergraduate degree. So without further ado, let's just get straight into the video. So to begin, what is a mechanical engineer? And for that, I think we'll just go to Google and type in the definition of a mechanical engineer. And the definition pretty much says that a mechanical engineer or mechanical engineering is a branch of engineering that combines physics, mathematical principles with material science to design, analyze, manufacture, and maintain mechanical systems. So from that definition alone, I think it really encompasses what being a mechanical engineer is. You definitely need to know all these fundamental principles in order to be a successful mechanical engineer. So you may not know what these principles are, but they heavily relate to physical systems when it comes to mechanical systems. But there is another branch of mechanical engineering that deals with energy that you can also pursue. So if these concepts sound interesting to you, then you may want to choose mechanical engineer as your career of choice or as your undergraduate major, right? Yeah. One thing that I wanted to touch on as it pertains to mechanical engineering is that for me, I see mechanical engineer in three domains. So what I mean by that is you have your first domain, which is the thermal and fluid sciences. So these have to do with courses like fluid mechanics, heat and mass transfer, thermodynamics. So basically how energy is transformed through or transferred through fluids and mass. So, we have different types of ways that energy is transferred, maybe through convection. So like on a hot day, for example, if you are hot, right, and you turn on a fan and the fan is blown on you, that is convection, right? Air, which is fluid, it is taking some heat off your body. So it's taking some energy off your body. So that is a whole branch of mechanical engineering. And honestly, in order to actually get a job in that kind of branch of mechanical engineering, you have to pursue a graduate degree. At least for me, the coursework that I took at Purdue, I felt as though was not sufficient enough to land you as a job as a thermal engineer at Apple, for example. Applications for the thermal and fluid sciences had to do with cooling a chip, for example. Like the chips that we use in computers gets really, really hot, right? So finding a way to cool that down requires a lot of math, requires a lot of physics, and requires a lot of expertise, which I don't think that is something that your undergraduate degree would not be able to give you. So that is one branch of mechanical engineering that you can hone in on or get focused in on. So there's that. And another branch is the electromechanical sciences. So these has to do with your control systems, ECE courses, so electricity and optics, microcontrollers, building feedback loops, for example. So for this branch of mechanical engineering, if you think about something like a thermostat, for example, the thermostat constantly measures the temperature of the room, right? So if your desired temperature is set to 70 degrees and maybe it's a hot day outside, so it's hot outside, so as a consequence it's going to be hot inside as well. So if the temperature of the room goes above 70 degrees, then your AC kicks on, right? So that is a sort of feedback loop in the sense that it is always reading the current state or the current temperature of the room and trying to adjust that and set that to your desired temperature, which is 70 degrees. So there's a whole branch of mechanical engineering dedicated to electromechanical systems and feedback loops, which you can focus on if you choose to do so. Or the last branch of mechanical engineering, as it pertains to my definition, would be the mechanical science. So the mechanical science have things to do with like statics, dynamics, mechanics of materials. So you learn about materials and the properties of materials, but You can also get specific when it comes to mechanics and materials. There's a whole course, or there's a whole major rather, dedicated to material sciences that you can study. So that is just a whole other thing. But when it comes to things like statics, dynamics, some of the forces, friction, for example, all those things can be grouped up into the mechanical science under mechanical engineering. So throughout my undergraduate degree, I covered all these three domains. You get to take courses in all these three domains, get to see what you like, get to see what you are interested in, and then, if you choose to pursue higher education, graduate degree, then you can focus in on one of these domains. And usually what happens is that throughout my undergraduate degree at Purdue, they had design courses that allowed you to tie all the knowledge that you would get from these three domains. So in the design courses, you can, build a cart, right? And in order to build a cart, you need to be able to know what kind of forces the cart can withstand, right? So that has to do with your mechanical sciences, right? You have to calculate the sum of the forces, how heavy the cart is, what forces, like I said, can the cart withstand, and then if the cart has to be autonomous or move by itself, then that is where your electromechanical science comes in, right? So I actually did a project on this where we had a little toy robot that was able to traverse through an obstacle course. And for that, if the robot is diverting too far from the course, you need a way to adjust that or bring it back onto the course. So that is where your feedback loop comes in. So that is where your electromechanical sciences come in. And for the other one, I guess that project that I did really did not have any fluid applications where you had to worry about energy being transferred through mass or through a fluid, but there's definitely applications when it comes to that sort of domain in mechanical engineering. So throughout your course at Purdue, or throughout your course in your undergraduate degree, I hope you get the chance to tap into all these three domains and figure out what you want. I'm pretty sure that is standard amongst all undergraduate programs when it comes to mechanical engineering. So you will definitely get a chance to touch on all of these domains and then have a way to display your expertise through the design projects that you will inevitably have to do. So is it hard? Oh man. Personally for me, I would say it was it hard? Yeah, it was pretty difficult. Because the reason that why I think mechanical engineering is pretty difficult is because it is very theory based. The things that I talked about when it comes to the thermal sciences, for example, or the electromechanical systems. Yes, you do get a chance to see it in actual practice, during labs and stuff like that. But when it comes to learning things like the Bode plots or learning about convection, learning about conduction, it's hard to basically so in order to actually understand the key concepts, you have to do a lot of differential equations and stuff like that, especially when it comes to the thermal sciences. You need to be really good when it comes to your DFQs and your differential equations. So going through a coursework like that, if you are not really good at math, or you are not really math is not your thing, then you might find it a little bit difficult. So I'm not gonna stand here and say it's easy. That would be a lie. It definitely requires a lot of work. So is it difficult? Out of a scale from 0 to 10, I would rate it maybe an 8 when it comes to difficulty of the major. The next question is, do you need a passion for these topics in order to pursue mechanical engineering? I would say no. You do not need a passion for these topics to pursue mechanical engineering. Honestly, I think if you are someone who is very curious, wants to learn a lot about every single thing that you see, but okay, not every single thing that you see, but you are a curious person, you like to learn a lot about a lot of things, then mechanical engineering is a good fit for you. Like I said, you do cover a broad range of engineering principles, all the way from electrical systems all the way to static systems. Like, for example, a bridge. The bridges don't really move, but you study the science behind how a bridge is actually made, what kind of materials they use to build that bridge. There's even you can get so granular to the point that you learn about the type of bolts that are used to put the bridge together. And obviously it makes sense, right? You want to make sure that every single thing that you do, or every single thing that goes into designing that particular bridge is well thought out. So you will learn about all these things. Granted, you don't have to like every single thing that you learn, but you would have to get at least a basic understanding of these principles in order to be an effective mechanical engineer. So do you need a passion for all of this? I would say no. Just be someone who is curious, someone who likes math and science, and you would be fine as a mechanical engineer. What are the career prospects? So for this question, I would say you can do a lot with the mechanical engineering degree. You can basically become anything that you want as a mechanical engineer. Not basically anything that you want, but there's a lot of job opportunities as a mechanical engineer. You can find yourself working in so many industries around the world. So my experience lies with the automotive industry when it comes to mechanical engineering. I got to intern for Honda out of Ohio 2 consecutive summers, building cars. So that is where my mechanical engineering, degree took me. But right now I work in tech. I don't really do mechanical engineering anymore. But with my experience as a mechanical engineer when I worked for Honda, I would say that prior to the pandemic hitting, it was very easy for me to get a job as a mechanical engineer. There's a lot of factors that goes into that, being a citizen and stuff like that, citizen of the United States, because I know that for some companies, they have to be really strict on who gets to work for them, because they do partner with the government for a lot of, delicate projects when it comes to, building planes for the government, or building certain, I don't want to say weapons, but building certain automobiles for the government. They have to make sure that people working on those designs are US citizens. So if that is not an issue for you, then you should be fine, because I do have a lot of friends who are finding it difficult to get a job because they're not a citizen or something like that. So that is the only way that I will see you struggling to get a job. But if you are a citizen of the United States, you should be fine. You should have the ability to work for pretty much any industry in the world, to be honest. I don't see an industry where a mechanical engineer will not be useful. When it comes to obviously building cars, you need mechanical engineers. But when it comes to and when I say any industry, I'm talking about the engineering industry as a whole. Places that make physical things, you need a mechanical engineer to be there. If anything, anywhere that makes physical things, a mechanical engineer will be useful. But when it goes to fields like accounting, right, it doesn't make any sense. So you should be fine. The career prospects for mechanical engineers pretty high. If, like I said, if you are a U.S. citizen, the sky is the limit for you. How competitive is it? So I think this is a really interesting topic to discuss, because let me speak on my experience for Purdue University. So Purdue University, during my freshman year, at a seminar, they told us that, so the average GPA for a graduating senior in mechanical engineering is about 3.2, right? And that's pretty competitive, especially with what you're going to be going through, throughout your undergraduate career. That is pretty competitive. So, but that was at Purdue University. I don't know how it is at other places, but know that you are competing with a bunch of smart people who love math and science and are curious, and people who will spend countless hours, studying and working So that is your competition. So be prepared for that. So is it competitive? I would say definitely yes. But my advice would be to get a group of people that you work with. I think that is definitely something that helped me out. Is I had a group of people, at least closer to my closer to junior and senior year. I had a group of people that we were taking the same classes, so we would help each other study, help each other with the coursework and stuff like that. It made life so much easy. Prior to that, I was trying to do everything by myself, and man, let me tell you, you would spend countless hours studying, and that is not what you want to do. College, yes, you are there to get your degree, but you want to make the best out of the opportunity that you have when you are in college, and definitely have some fun. And one of the ways to do that is to have a group of people that you study with, so that you don't have to worry about doing everything by yourself, right? What kind of jobs do you do as a mechanical engineer in the industry? So I would speak on this through my experiences with my internship at Honda. And I would say that with Honda, the domain that was heavily emphasized in mechanical engineering is going to definitely be the mechanical sciences. So, building structures, figuring out the forces on those structures, the moments on those structures, the stresses on those structures. That is definitely the domain that was emphasized at Honda where I worked. I know there's other industries where you have to worry about the other domains, but from my experience, we're building cars. You need to know how heavy the car is. You need to know how much weight the car can take. You need to know that if something hits the car, what would happen to the materials that make up the car? How would it mangle? So those are the things that I was focused in, and a lot of the work had to do with CAD. You had to be good at CAD, and it got to the point where I was asking a lot of the engineers, since everything is so abstracted to the point that we design a door in CAD, and in the CAD software that we use, which is CATIA, it had applications that allowed you to calculate the mass of the actual door that you created, the center of mass. These are key principles that you need to know in order to understand how the door will behave under certain stresses, right? So it automatically calculated the center of mass of the object that you created. It calculated the weight of the object that you created. It allowed you to apply materials to the object. It allowed you to simulate how the actual door will fold and mangle under certain conditions or under certain pressures. So so it kind of takes away that whole ground root, manual calculations that you have to do, where you actually have to list out the equations, some of the forces, list out all the moments, and do everything by yourself, because those applications already abstracted it for you. All you had to do was design the actual object. So it got to a point where I was asking them, okay, so since this is so abstracted, it feels like my contribution to the overall design is heavily dependent on my ability to use CAD, right? And that definitely was an issue that I was facing. I felt as though I wasn't getting the opportunity to, show off what I learned from school. It's more so, design this object, make sure all the parameters are, well in order, and then you should be good to go. So that is, if that sounds like a worry to you, I would definitely say that maybe you may want to go into other industries or other domains where other skills are needed. But when it comes to industries like the automotive industry, you're going to be working with CAD, especially when it comes to design. When it comes to design, you're going to be working with CAD. I know other mechanical engineers that worked in the automotive industry, but then we're focused on the electromechanical systems, or we're focused on the fluid systems, right? And for those kind of systems, having that ground root understanding of the fundamental equations and having a basic understanding of how these systems will behave under certain conditions, I think definitely makes you a better engineer, right? So depending on where you go, you might use the other domains, but as it pertains to me and my experience at Honda, I was doing a lot of CAD. And if you want to know my experience at Honda, leave a comment below and I'll be sure to get to it. But yeah, overall, hopefully this gave you an understanding of what being a mechanical engineer is at Purdue. I know there's a lot of things that I didn't get to, but if you have any questions, leave it down in the comments below. I hope this helped. I hope this gave you an understanding of what mechanical engineering is. You know, I know personally for me, that's definitely information that I didn't have, and I wish someone had told me. But you know, having someone that has gone through that entire process and having someone look back on their experience as a mechanical engineer and tell you about it, I think is very useful. And I want to be able to, you know, give you that information. So yeah, that is it for this video. If you have any questions, just leave it down in the comments below and I'll be sure to make a video about it. But yeah, thank you so much for watching and I'll see you in the next video.